Welcome back, everyone. We're diving into the world of small engines today.
Oh, yeah.
We've got a whole pile of technical manuals, lab instructions, all sorts of things.
Sounds like fun.
Our mission, should we choose to accept it, is to figure out how these things tick.
Okay.
And I think we're going to go a little deeper than just scratching the surface.
Yeah, I'm ready.
Get into some of the really cool engineering behind these little powerhouses that we find everywhere, right?
Yeah, the amount of engineering that goes into these small machines is pretty amazing.
You think about it, it's like a miniaturized version of like a car engine. A
Mm-hmm.
lot of the same principles.
Yeah, controlled explosions turned into usable work.
Yeah, it's wild.
Yeah.
So let's start with a classic, the four-stroke engine.
Okay.
Everyone's heard of the four strokes: intake, compression, power, and exhaust.
Right.
But what's actually going on in there?
Well, that intake stroke, that's where it all starts.
Yeah, that's where we're bringing in the fuel and air mixture.
Right, like taking a deep breath.
Yeah.
And you got to have that intake valve doing its job.
Oh, absolutely.
Not just opening at the right time, but also sealing tight during compression.
Yeah, if you don't have that good seal, you're losing power.
Exactly.
I was reading, and this is a fun fact, intake valves, they run cooler than exhaust valves.
Oh, that's interesting. Why is that?
You would think it would be the opposite, but it's because that intake charge, that fuel and air mixture coming in, it's actually cooling things down a little bit.
Oh, I see. So it's like a little built-in air conditioner for the intake side.
Yeah, kind of. And then you move into compression,
Mm-hmm.
and now things are getting hot.
Right, you're squeezing that fuel-air mixture.
Yeah, squeezing it.
It not only makes it more explosive, but also creates more heat.
Yeah, and the amount of squeeze you're giving it.
Right? Yeah.
That's your compression ratio.
Yeah.
And if you squeeze too much,
You don't want to go overboard.
that's where you run into pre-ignition, right? And
Mhm.
you're basically lighting the firework too early.
Right. Not good for the engine.
You want it all to happen at the right time.
Exactly.
And then, boom, the power stroke.
That's the start of the show.
Yeah, that's where all that energy gets released.
Pushing that piston down with incredible force.
Yeah. I was reading that the spark actually has to happen a tiny bit before the piston reaches the very top.
Timing is everything.
Yeah, like trying to hit a fastball at the perfect moment.
All about maximizing that power.
And then we wrap it all up with the exhaust stroke.
Get rid of those spent gases.
Out with the old.
Yeah, clear the stage for the next cycle.
So it's kind of like breathing, right?
I like that analogy.
Inhale, compress, explode, exhale.
And that exhaust valve plays a big role too.
Oh, yeah, just like the intake valve. It's got to seal tight.
Make sure those gases flow out smoothly,
Mm-hmm.
kind of like the tailpipe of the engine.
Now, for all this to work, you need lubrication.
Of course, you got to keep things running smooth, literally.
And four-stroke engines, they use a combo of splash and pump systems.
Yeah, they've got a pump circulating that fresh oil.
But how does it get to all the nooks and crannies?
Well, there are some clever little tricks in there.
Okay.
Sometimes they have like a little spray nozzle aimed at the crankshaft.
Really?
Yeah, and as it spins, the oil gets flung off and hits other parts.
It's like a miniature oil sprinkler system.
Yeah, kind of.
Yeah.
And then there's this thing called a splash finger.
A splash finger.
Yeah, it's like a little projection.
Okay.
It dips into the oil, and as it rotates, it flings oil onto the internal surfaces.
Wow. And I also read that there's a dedicated oil tube for the governor.
Ah, yes, the governor.
Yeah.
Got to keep that engine speed in check.
Yeah. So every little detail has been thought out.
It's pretty impressive.
But even with all that, they still need regular oil changes.
And got to keep them upright.
Yeah. That's a limitation of the four-stroke design.
Right.
Which brings us to the two-stroke engine.
Ah, the rebel of the engine world.
Yeah. These guys, they cram the whole four-stroke cycle into just two strokes.
That's right. Power stroke every revolution.
They're known for their power-to-weight ratio.
And they're simpler.
Simpler? How so?
No valves, no camshaft.
So they're simpler, they're more powerful, they can operate at any angle.
Yep, they've got a lot going for them.
What's the catch? There's got to be a catch.
Well, one thing is you got to pre-mix the fuel with oil.
Okay.
So the oil gets burned along with the fuel, provides that continuous lubrication.
Interesting. So it's like a built-in oil change every time you fill up.
In a way, yeah.
Yeah.
But that does mean more emissions.
Yeah, that makes sense.
So you see two strokes in applications where those advantages really shine.
Yeah, like lawnmowers, chainsaws, snowmobiles.
Exactly, where that power-to-weight ratio and the ability to operate at any angle are really important.
Have you ever used a two-stroke tool?
Oh, absolutely.
Yeah.
Growing up, we had a chainsaw for cutting firewood, and that sound, it's
Yeah.
just unmistakable.
You can always tell a two-stroke.
And now, I know there are different types of two-stroke engines, too. Right. You guys are cross-scavenged and you're loop-scavenged.
What's the difference?
It's all about how they manage that flow of gases inside the cylinder.
Okay. So with a cross-scavenged engine, how do you keep that fresh air-fuel mix separate from the exhaust?
That's where the piston design comes in. It's got this baffle on it.
A baffle.
Yeah, it's contoured in a way that directs the fresh charge upwards and stops it from going out the exhaust port.
So it's like a little traffic cop in there.
Yeah, exactly. Guiding traffic, making sure everything flows the right way.
And I was reading that some of them use reed valves or rotary valves.
Right, to hold that fuel charge in the crankcase until it's needed.
Kind of like temporary holding chambers.
You got it.
And what about loop scavenge?
Loop scavenge, they don't have that baffle on the piston.
Oh, okay.
They rely on these carefully placed transfer ports,
Okay.
and those ports create this swirling motion in the cylinder.
So instead of a traffic cop, it's like a little tornado in there.
Yeah, that's a great way to put it.
So regardless of the type, they've got these ports: exhaust, transfer, and intake.
Yeah,
And I noticed the placement is pretty specific.
very specific.
Exhaust is highest, then transfer, then intake at the bottom.
It's all about timing and efficiency.
So as the piston goes up, what happens?
Well, first, it covers the intake port, seals it off.
Okay.
Then, as it keeps rising, it uncovers the exhaust port, letting those gases out.
It's like opening a window to let the smoke out.
Exactly.
Yeah.
And while that's happening, the piston is also compressing that fuel oil mixture that's been hanging out in the crankcase.
Okay.
And when it uncovers the transfer port, boom, that pressurized mixture rushes into the cylinder.
Wow. So it's like a carefully choreographed handover.
Exactly.
Old gases out, new mixture in.
And all this is happening while the piston is still moving up.
That is amazing.
Right.
So the piston reaches the top
Right. Compresses that fresh charge.
and then spark.
Power stroke time.
And I read that the timing of that spark can actually be adjusted depending on the speed,
Yeah, for better efficiency at higher speeds.
like fine-tuning the performance.
Exactly.
Now the piston goes back down.
Right.
What's happening on the way down?
So as it comes down, it first covers the transfer port. No more fresh charge coming in.
Okay.
Then it uncovers the exhaust port again, letting out any remaining exhaust gases.
So the piston is kind of acting like a valve itself.
In a way, yeah. Controlling the flow.
And meanwhile, it's also pulling in a new charge of air and fuel through the intake port.
The cycle continues.
That's just amazing how it all happens so quickly and smoothly.
Thousands of times a minute.
It's incredible, but getting those exhaust gases out efficiently, that's got to be crucial.
Oh, absolutely. And that's where the design of the exhaust system is so important.
Yeah, you don't want to be wasting any of that fresh fuel charge.
Right. Ideally, you want to hold that fuel charge in there for just a split second while that exhaust port is open.
But how do you do that?
Well, some exhaust systems use the energy of sound waves.
Sound waves?
Yeah, sound waves.
Okay, now you've got me intrigued.
So imagine like a megaphone shape in the exhaust system.
Okay.
And as those exhaust gases rush out, they create sound waves, right?
Mm-hmm.
Well, that shape amplifies those waves.
Okay.
And those amplified waves actually create back pressure.
Oh, interesting.
And that back pressure helps prevent the fuel from escaping.
So you're using the engine's own sound to improve its performance.
Pretty cool, huh?
That is very cool.
Yeah,
So we talked about reed valves and rotary valves earlier.
right.
Are there other types of valves in these engines?
Yeah, there's also the rotary disc valve.
Rotary disc valve.
It's often located right in the crankcase.
And why in the crankcase?
Well, that frees up space for more transfer ports.
I see. So better flow, better scavenging.
Exactly.
It's all about optimizing the flow.
Always.
Now, reed valves, I'm curious about those. How do they work?
Reed valves, they're pretty simple, really. Imagine a thin piece of spring steel
Okay.
fastened at one end, covering the intake port.
So it's like a little one-way door.
Exactly.
Air and fuel can come in, but they can't go back out.
Right. Atmospheric pressure opens it during intake, and then crankcase pressure and the spring close it during the power stroke.
So simple, but effective.
Very effective.
Now, we've been talking a lot about the theory here,
Mm-hmm.
but I'd love to get a better look at the actual parts.
Oh, yeah. Let's get hands-on.
Like, in those lab instructions where they have you take apart a small engine.
I love taking things apart.
I do too.
It's the best way to learn.
So imagine you've got all the parts laid out in front of you.
Okay, I can see it.
Flywheel, cylinder head, valves, piston, connecting rod, crankshaft, bearings, oil dipper.
It's like a mechanical puzzle.
And the instructions really stress handling those parts carefully.
Absolutely. You don't want to damage anything.
And paying attention to detail.
Every little piece matters.
It's like seeing the orchestra come to life after you've studied each instrument.
I love that analogy.
But like any machine, Engines experience wear and tear over time.
That's true.
What happens when those parts start to wear out?
Well, that's where engine reconditioning comes in.
Engine reconditioning.
It's like giving the engine a spa day,
Okay.
getting it back to its former glory.
What does that involve?
Well, it can involve a lot of things, depending on the engine, but it starts with a really thorough inspection,
Okay.
using precision measuring instruments to check clearances, tolerances, wear patterns.
So it's a very meticulous process.
It is, very much so.
What kind of tools do you use for those measurements?
Oh, things like micrometers, feeler gauges, Plastigauge.
Plastigauge.
Yeah, it's a special type of gauge for measuring bearing clearances.
So you're measuring incredibly small distances.
Thousandths of an inch.
Wow, that's precise. So you've found some worn or damaged parts. What next?
Well, sometimes you can recondition the existing parts,
Okay.
like honing the cylinder, for example.
What's honing?
Basically, you're smoothing out the inside surface of the cylinder.
Okay.
Make sure it seals well with the piston rings.
And the valves. I imagine those get a lot of wear.
They do. Sometimes you can lap the valves.
Flapping?
Yeah, use a lapping compound to create this perfectly smooth, even surface
Yeah.
between the valve and the valve seat.
Oh, okay, so you're polishing them.
In a way, yeah. And then there's checking the ring gaps.
The ring gaps.
Yeah, those are the little spaces between the ends of the piston rings.
Okay.
They got to be just the right size.
Why is that?
Well, it affects the sealing and the oil control in the cylinder.
So many little things to consider.
Yeah, it's all connected.
Speaking of little things, let's talk about the flywheel.
The flywheel.
Yeah. It seems like a simple part, but I bet it's more important than we think.
Oh, it definitely is. It's essentially a rotating mass that stores energy.
So like a battery for rotational energy?
Exactly.
Yeah.
And that energy helps to smooth out the engine's operation.
How so?
Well, remember, those power strokes happen in pulses. The flywheel helps even those pulses out. Creates a smoother rotation.
So it's like a shock absorber for rotational forces.
Yeah, kind of. And it also helps to start the engine.
Oh, how does it do that?
When you pull that starter cord or hit the electric start, you're spinning that flywheel.
Okay.
And that initial spin helps the engine overcome inertia, get those first few cycles going.
I see, like giving it a push start.
Exactly.
Now, the instructions, they say to inspect the flywheel for cracks, damage, weakened magnets.
Yeah, all important things to check.
Why are those so important?
Well, a cracked flywheel, that could be dangerous. It could fly apart while the engine's running.
That's not good.
No, definitely not. And weakened magnets, they could reduce the spark strength.
Oh, so it's not just a hunk of metal.
Not at all.
There's a lot going on in that flywheel.
Yeah,
And installing it correctly, that's got to be crucial too.
absolutely. Securely fastened, make sure the key, the washer, the rewind starter assembly, all in the right places.
It's like the foundation for the whole rotating assembly. It's exactly.
Wow, we've covered a lot of ground today.
We have.
From 4-strokes to 2-strokes, lubrication systems to valve designs.
Yeah.
It's amazing how much goes into these seemingly simple machines.
Yeah, it's a testament to human ingenuity.
Absolutely. Now, we've only just scratched the surface.
We have a lot more to explore.
So where do we go from here?
Well, in our lab instructions, there's this whole section on disassembling and inspecting a small engine.
Oh, yeah.
I think it'd be really cool to actually walk through those steps.
Oh, I'd love to.
See what to look for, how to spot potential problems.
Looks like we're going to get our hands dirty next time.
Figuratively, of course.
Well, maybe. Let's find out.
Okay, I'm game.
All right, let's do it.
Awesome.
I'm excited. Okay, so we're going to roll up our sleeves now, get a little more hands-on.
Time to get into the nuts and bolts.
Yeah, literally. We're going to walk through the disassembly of a small engine using our trusty lab instructions as our guide.
Sounds good.
It's like we're right there in the workshop. I can hear the tools clanking already.
All right, so first up, the flywheel.
The big spinning disc at the back.
Yeah, it's that heavy thing, stores rotational energy.
Right. Help smooth things out.
Yeah. And I'm looking at this. How do you even get this thing off?
Well, you're going to need a special tool.
Okay.
A flywheel holder.
Flywheel holder, okay.
Keeps it from spinning while you loosen that nut.
And the instructions, they really stress safety here.
Oh, always got to be safe.
Disconnecting that spark plug wire.
Absolutely. Don't want any accidental sparks flying around.
No, not good.
I get it all.
All right, so we got the flywheel off. What are we looking at here?
All right, so a few key things to check.
Okay.
Make sure there are no cracks, no damage.
A crack would be a bad thing, right?
Oh, yeah. You don't want that thing flying apart while the engine's running.
No. And what about the keyway?
Keyway. That's that little slot that aligns the flywheel with the crankshaft.
Okay.
Make sure that's not damaged either.
Because if it's damaged...
It could cause the flywheel to slip.
Oh, that would mess up the timing.
Big time.
All right, so the flywheel's good to go.
What's next?
Let's move on to the cylinder head.
The brain of the operation.
Yeah, the top part with the valves, the combustion chamber, the whole shebang.
Okay.
The instructions, they're very specific about removing the head bolts.
Oh, yeah, there's a specific order.
In a certain sequence. Why is that?
You want to make sure the head comes off evenly.
Okay.
You don't want to warp it or damage anything.
It's like when you're changing a tire on your car.
Yeah, you loosen those lug nuts in a star pattern.
Some idea, distribute the force evenly.
Exactly.
Okay, cylinder head's off, now what?
All right, let's take a look at that head gasket.
That thin little thing.
Thin but crucial. It's the seal between the head and the engine block.
Yeah, keeps everything from leaking.
If that gasket's damaged, you're going to have problems.
Loss of compression, all sorts of things.
Exactly. And we also want to check the head itself.
Oh.
Cracks, warping.
Make sure it's nice and flat.
Yeah, nice and flat.
Yeah, the valves, those guys get a workout, right?
Thousands of cycles per minute.
They're constantly opening and closing.
We need to check those for wear and tear.
And carbon buildup, I bet.
Oh, yeah. Especially if the engine hasn't been running right.
What about the valve springs?
Got to check those too.
Those are the things that, like, snap the valve shut, right?
They provide that force to close the valves quickly.
Okay, and I'm seeing the camshaft here in the instructions.
Ah, the camshaft, the valve maestro.
Yeah, it controls when the valves open and close.
We got to check those lobes for wear.
Lobes?
Yeah, those are the bumps on the camshaft.
Okay.
They push on the valves to open them.
Oh, I see. And what about the timing marks?
Timing marks are crucial. Got to make sure they're lined up with the crankshaft.
Keep everything in sync.
Otherwise, the engine won't run right.
All right, let's move down to the cylinder itself.
Heart of the engine.
What are we looking for here?
We're looking for any wear and tear scoring.
Scoring. What does that mean?
It's like scratches, grooves.
Oh, okay.
You'll need a micrometer to measure the cylinder bore.
That's that precise measuring tool, right?
Yeah, you got to check the top and bottom of the cylinder.
For...
Taper out of roundness.
So you're making sure the cylinder isn't worn out of shape?
Exactly. If it is, you might lose compression.
Not good.
No, might need to rebore the cylinder or even replace it.
And then there's the piston and rings.
Those are key for sealing the combustion chamber.
Yeah, and transferring that power to the crankshaft.
Right. You'll need a ring expander to get those piston rings off.
Carefully, I imagine.
Very carefully. You don't want to break them.
And then you check the rings for damage?
Wear, cracks, anything that looks off.
Okay. The instructions mention piston skirt clearance.
Ah, yes. That's the space between the piston and the cylinder wall.
Okay. Why is that important?
If it's too tight, the piston could seize up.
Oh, not good.
And if it's too loose, you'll have noise, oil consumption.
Oh, it's got to be just right.
Goldilocks zone for the piston.
Now, this is all fascinating stuff.
It's pretty amazing how everything works together.
But we've been talking a lot about four-stroke engines.
Right.
What about disassembling a two-stroke?
Two-stroke disassembly, it's similar, but simpler in some ways.
Simpler.
Yeah, remember, no valves or camshaft in a two-stroke.
Oh, right.
So you don't have to worry about those.
Okay, that makes sense. And the lubrication system is different, too.
Totally different. Oil mixed right in with the fuel.
No separate oil sump or anything?
Oh,
so you'd focus more on the cylinder, piston, rings, those ports?
Exactly, the parts that handle the gas flow.
So whether it's a four-stroke or two-stroke, taking it apart.
It's a great way to really understand how it works.
Yeah, and see if anything needs fixing.
Exactly, like a little engine checkup.
Okay, so we've got all our parts inspected.
Time to put it back together.
The reassembly process, that's a whole other adventure.
It is, but just as important as the disassembly.
And I'm sure just as many details to pay attention to.
Oh, absolutely. We'll need all the right tools, the right techniques.
To make sure everything goes back together just right.
And torqued to the proper specifications.
Now that sounds like a topic for another time.
Yeah, we'll save that for our next deep dive.
All right, so next time, we'll explore the art of engine reassembly.
Getting that engine purring like a kitten again.
I can't wait. Okay, so we've got our engine all laid out, parts inspected, and it's time to put it all back together.
It's like putting together a puzzle.
It is. But this puzzle, it comes with a lot of torque specs and special tools.
That's right. We can't just slap it together. Precision is key here.
Absolutely. Our trusty lab instructions are going to be our guide. They really stress the importance of using torque wrenches for this step.
Oh, yeah. Torque wrenches are your best friend when reassembling an engine.
Why is that?
Well, you got to tighten those bolts just right. Too loose, and things could come apart. Too tight, and you could strip threads or even crack something.
Not good.
Not good at all.
So where do we begin?
Well, let's start with the piston and connecting rod assembly.
Back into the cylinder.
Yep, got to get those piston rings in there just right.
I remember those being a bit of a pain.
Yeah, they can be tricky. You'll need a ring compressor to squeeze those rings down and guide the whole assembly into the cylinder.
And everything's got to line up perfectly.
Absolutely. Once the piston's in, we attach the connecting rod to the crankshaft.
Don't forget the lubrication.
Of course, got to have those bearings nice and
Yeah,
slick.
assembly lube, right?
The best.
Okay, what's next?
Crankshaft goes in next, making sure it's properly seated in those bearings.
It's starting to look like an engine again.
It is, isn't it?
Mm.
Now for the valves and the camshaft.
The breathing apparatus.
Exactly. And those valve springs, those can be tough to handle.
They're strong little buggers.
Oh yeah, you need a valve spring compressor for those. Compress those springs, get the retainers in to hold the valves.
Okay, and then the camshaft?
Camshaft goes in carefully, making sure it's timed right with the crankshaft,
Everything's got to be synchronized.
just like a well-rehearsed dance.
Okay, so valves and camshaft are in. Now what?
Now, we put the cylinder head back on with a new head gasket, of course.
That little paper-thin thing, but so important.
Absolutely crucial for a good seal. And then we tighten those head bolts.
In that specific sequence we talked about earlier.
That's right. And with the torque wrench, get that precise tightness.
It's amazing how such a small thing can make such a big difference.
It's all about the details.
Right.
All right, cylinder head is on. Now we can move to the outside.
Like the flywheel.
Yep, flywheel goes back on. Make sure it's keyed correctly to the crankshaft. And then the ignition system.
The spark maker.
Exactly. That's what gets the whole combustion process going.
I'm curious about the ignition system. How does that actually work?
Well, you've got the coil, the spark plug, and a way to trigger that spark at just the right time. Some engines use the flywheel itself to trigger the spark.
How does that work?
The flywheel has magnets on it,
Okay.
and as it spins, those magnets pass by the coil.
Okay.
That creates a pulse of electricity.
Ah, like a mini generator.
Exactly. And that pulse goes to the spark plug, jumps the gap, creates the spark.
And the gap on that spark plug, that's got to be just right, too, right?
Oh yeah, it's critical. Too wide, and the spark might be weak. Too narrow, and it might not spark at all.
So many variables.
You got it. You'll
I
need a
love it.
spark plug gap gauge to set it just right. And we also want to make sure the spark plug itself is in good shape.
Okay. Ignition system's all set. What's next?
Carburetor time.
The fuel and air mixer.
Yep, the carburetor makes sure we have the right blend for combustion.
Like a chef, getting the recipe just right.
Exactly. We mount the carburetor, connected to the intake manifold, and then we adjust the settings.
Settings like...
Idle speed, fuel-air mixture. Got to make sure it's running smooth.
So there's some fine-tuning involved.
Oh yeah, this is where the art comes in.
Mm-hmm.
Getting those settings dialed in just right
Yeah.
makes all the difference. And you know, there are different types of carburetors.
Really?
Yeah. Some have a fixed venturi, others have a variable venturi.
What's a venturi?
It's that narrow part in the carburetor.
Okay.
And it creates a pressure difference that pulls the fuel into the airstream.
Okay.
A variable venturi can change size depending on how the engine's running.
So it's like a dynamic chef.
Exactly.
Mhm.
Adjusting on the fly for better fuel economy and performance. And some carburetors have multiple jets, too.
Jets.
Little openings that control the fuel flow. Adjusting those can really fine-tune the mixture.
So much complexity in such a small device.
That's pretty amazing. All right, carburetor's in. Fuel tank next. Connect those fuel lines.
And double check all those connections. Don't want any leaks.
Absolutely not. Safety first.
Okay, engine's back together, ignition's in, carburetor set, fuel's connected. What now?
Time for the final inspection.
Make sure we didn't miss anything.
Exactly. Make sure everything's where it's supposed to be, all nice and tight.
Yeah.
Like a pilot doing a pre-flight check,
And don't forget the oil.
right? Got to add oil to the crankcase, make sure everything's properly lubricated.
Okay, the moment of truth.
You ready to fire it up?
Oh, yeah. Let's hear it run.
But first, safety first.
Yeah.
Make sure the area is well ventilated. That exhaust can be dangerous.
Right. Gotta be careful with that carbon monoxide.
All right, everything's safe. Let's do this.
Hit it.
Sound of engine starting. There she goes.
Wow, it's alive. That sound, it's like a symphony.
Music to our ears. And it sounds smooth, too. All that work paid off.
It really did. And to think, this is just a small engine. I can't even imagine the complexity of a big car engine or something.
Oh, it just gets more and more intricate.
Yeah.
But the basic principles are the same.
It's just mind-boggling to think about all the engineering and ingenuity that goes into these machines.
It really is. It makes you appreciate the simple things, like starting your lawnmower or your chainsaw.
You know, you're right. I'll never look at a small engine the same way again. Well, listeners, I hope you enjoyed our deep dive into the world of small engines.
We've gone from theory to practice, taken an engine apart, put it back together, and learned a lot along the way.
And it's all thanks to these amazing lab instructions that walked us through every step.
So the next time you hear that familiar roar of a small engine, take a moment to appreciate all the moving parts, all the precision engineering, all the clever design that makes it work.
And who knows, maybe you'll be inspired to tinker with an engine yourself. Until next time, keep exploring, keep learning, and keep those engines running smoothly.
See you next time.